It's coming to you as an option, record, showing you.
Yes, sir.
Is it
So it's
showing?
recording.
Okay.
It's showing
recording.
recording, sir.
Yeah.
Yes, yes. Showing it, showing.
For an object placed between 2f and f of the concave mirror, you have to prove one point was
You have to put
the
the image form
yeah,
is real and beyond 2f.
image is real and it's formed beyond 2f.
Yeah.
See, so many different ways you can do. What I started that day, it's a concave mirror, right?
Yes, sir.
This is the pole. This is f and 2f. So your object will be here.
Yeah.
So all these distances are negative, right?
Yeah.
So out of these values, which one is the highest and least?
If you take negative wise, the highest, since the f is the minimum in magnitude and it's negative, it will be the maximum.
Okay, that's why so many options. You should follow one and fix over that. I am following with the negative sign, the values.
Okay,
So
fine.
F.
So it will
So
be
f is the greatest.
f greater than u greater than
Greater than 2f.
2f. Fine.
Yes, sir.
Now I need to find the image. So as per my knowledge, 1 by v plus 1 by u is equal to what? 1 by f.
Yes, sir.
So 1 by v will be from that.
Or 1 by v is equal to 1 by f minus 1 by u.
So I should get 1 by f minus 1 by u to substitute somewhere as 1 by v.
Okay, sir.
So I have a u here.
Yes, sir.
So I can multiply throughout negative.
Yes, sir.
Because I want minus 1 by u here. Okay. So minus f, the sign will change, right? Yes.
Yes, sir. Yeah.
Yes, sir.
Minus u minus 2f. Now you got minus. Now take the reciprocal. Minus 1 by f. Again the sign will change. Here doubt in this sign change, you have to see on the side with practical numerical values. 2, 1 by 2, minus 2. Is it fine? Till now?
It's fine, sir. Yeah.
Minus 1 by u greater than minus 1 by 2f.
Yes, sir.
Then I'm looking on the, yeah.
Can you give me permission to record?
I'm
It's
recording.
recording.
Oh, okay.
Yeah, it is. Top right, it says.
Okay.
Okay.
Yes, sir.
So now if I look on the right hand side, I have till minus 1 by u till here. I have here. Now I
Yeah.
want 1 by f on the added part along with that. So add 1
So
by
then
f.
you have to add.
Yeah.
Yeah.
So adding 1 by f, what will come? Left hand side will be
0.
0,
Then
1 by v.
yeah, that is 1 by v. Then
1 by 2f.
1 by 2f.
Yeah.
So
So now you take reciprocal again.
yeah, now one part is proved already. All the values are less than 0, right?
Yeah.
If 0 is greater,
Yeah.
that means v is negative, right?
Yeah.
V negative for a mirror, it means
It's behind. So like,
it's real.
yeah, it is real.
For a mirror, V positive is virtual and V negative is real.
Yes, sir.
So opposite for the lens, okay?
Yes, sir.
So now you proved the image is what real.
Yeah.
Now take the reciprocal of this. Still come. I only want these two terms. Even that also fine. V is less than 2f, right?
Yeah.
So already here 2f is here.
Yeah. And then since you have negative, it's like beyond.
Yeah, less than 2f means come here, right?
Yeah. Understood, sir.
Even you can do the other way without taking only the magnitude. It will come same. Then it will be reverse. V is greater than 2f then.
Yes, sir.
It will come. You can try anyway.
So then the others also similar to this only, right?
Yeah. The others are all easy actually. Not even this much lengthy. 5 steps, 4 steps.
So what do we have to prove, sir?
I have to prove in this case the image is real and it's
Yes, sir.
beyond 2f.
So how do you do the first one? There until the reciprocal, I just went to wash my hands.
Yeah, till where you're okay now?
So,
Till where you understood?
so until the reciprocal part.
Reciprocal part means?
The one here, sir. I'll show you. This one.
Yeah, tell me step 1, step 2, step 3 or top. I wrote step top also.
This
Yeah,
one, sir.
okay, yeah. Okay, so reciprocal is clear to you.
Yes, sir.
Then I'm seeing the right hand side here. I have
One
minus
second,
1
I
by
can't see
you.
that.
The right corner, right
Minus
down.
one. Yes, sir. But
Dude,
Okay,
minimize sir's screen.
oh yeah, I got it. Yeah.
Oh, the picture
Okay.
is there, that's it. Okay.
Yeah.
Yeah.
So I want 1 by f minus 1 by u, right?
Yes,
For
sir.
replacing as 1 by v.
Yes, sir.
So here only minus 1 by u. So I add 1 by f with all.
Okay, sir.
So left hand side will become 0. Here on the left top.
Yes, sir.
Then the middle part will
So
become
you add 1 by f to both sides.
oh, yeah, all the sides, all the 3. Along with all the 3 terms.
Okay, sir. Oh, okay, sir. Okay, sir.
Yes. Then I reach the top.
Yes, sir. Yes, sir.
Is it fine?
Yes, sir. Yes.
Amir?
Sir, I got you, sir. Understood, sir.
Shani sir.
Yeah.
Sir, in the first step, f is greater than u is greater than 2f. You're taking it as negative, right?
Yeah, I've taken with the values.
Okay. Then next step, you're adding negative. That's why it becomes positive.
Yeah.
And, okay.
See, that all comes with respect to the value I want here. I'm seeing this.
Okay.
Keeping this in mind only, I'm changing. I want a negative, I applied negative. Okay.
Okay.
I want 1 by u, I taken the reciprocal. Then I want 1 by f minus 1 by u, I added 1 by f with all. That's the aim behind me. I'm keeping this as the
Okay, sir.
destination to substitute 1 by f minus 1 by u as 1 by f.
So you're breaking. Yeah.
Yeah, yeah.
Your voice is breaking.
Yeah. Even it can be done without the negative also. So you get the other way, opposite.
Is Sir's video stuck?
Yeah, it's
Okay.
Is it fine? Amir? Amir? Amir only asked, no? Hello? Can you hear me?
Yeah, so now it's
Sir,
okay.
Yes, sir. Now we can hear you.
Yeah.
Yes, sir.
So my doubt comes like over there. 1 by v is less than 0.
1 by
So like
v is,
v,
yeah.
yeah. So like v will be like, if you take reciprocal, v will be greater than infinity.
Yeah. It will be,
So like greater than infinity, right? If you take the reciprocal,
we take a reciprocal,
1 by 0 less than v.
1 by 0 will be infinity.
1
Right?
by 0.
Infinity.
Sir's gone again. Sir, can't hear you.
Seem we having a losing man.
Yeah,
Can you
same thing
see
happened.
what I'm
Yeah, a while
writing?
ago.
Can you see the top line what I'm writing?
Yes, sir.
Yes,
It comes
sir.
like that.
Yeah, this
Yes.
is what comes, right?
Yeah.
Yes, sir.
Yeah, what happened wrong with that, Amir?
V is greater than infinity, so how is that real?
It's all are
So
negative already, right?
Yeah, okay, fine.
So this,
So then it's like, if V is greater than infinity, that's like way like behind, right?
yeah, V is beyond 2f.
Oh, okay, fine.
bro,
Negative
negative sign is
infinity.
there.
All values are negative. Okay.
Oh yeah.
Okay, sir.
It's like the first step.
Yeah, first step, correct.
So
Yes,
wait,
okay.
how is it negative?
Can you come
Get,
back to this step
according
and
to the
see
diagram.
this step? This step.
Yes,
What
sir.
is telling 0 is greater than all of them, right?
Yeah. Oh, okay. Yeah.
Or even Aditya told it's already here 2f, then it's all behind that be like till negative infinity going. It's common.
Yes, sir.
So
So then over
what
there
was
we
that
proved
second
that.
point, sir?
Sorry.
So what did you say like just now? So could you repeat that point?
No, I just told you as per the diagram also it's fine because you have 2f, then infinity means that side, left hand side.
Yes, sir.
Yeah.
So we've taken everything to be negative. That's what.
Yeah, it's already you got in that case already.
Yeah, sir.
Amir?
Yes, sir. So my next doubt is
Yeah.
this fourth worksheet is related to what we did last class, sir.
Okay, no problem.
It's the biconvex lens. The fifth question, worksheet 4. A biconvex lens of glass of refractive index 1.5 having focal length 20 is placed in a medium of refractive index 1.65. You have to find its focal length. And then second part of it, what should be the value of the refractive index of the medium in which the lens should be placed so that it acts as a plane sheet of glass.
Yeah. If you check the first part of the question, the glass is refractive index 1.5. Focal length is 20.
Yes, sir.
And they're asking what would be the focal length if you put this into another medium.
Yes, sir.
Yeah, so we can use that formula, lens maker's formula.
Yeah. The
1 by
only
f is
relation
equal.
connecting refractive index and focal length is lens maker's formula.
Yes, sir.
And
So
here
I think
So
I got
since
this
it's
when
a
I did.
it's a biconvex lens, so one of the R will be infinity, so it will become only 1 by R. There will be no
that is
1 by
No,
R.
infinity.
that is for plano-convex, not biconvex.
Yeah.
Oh, so what
Biconvex is
exactly?
like this, normal one.
Oh, okay.
Plano-convex, sorry, this is concave. Okay.
Yeah, convex.
Biconvex is like this.
Okay.
Yeah.
Plano-convex
So this
only.
question.
Huh?
So
Yes,
in
sir.
this question, sir, the ending part, what
Yeah.
should be the refractive index? For that part, we have to put P as 0, right? 1 by F is like 0.
Yeah, the medium should not have any divergence or convergence. The light should go straight.
Okay. Yes, sir. So then, okay.
First part, right?
Understood, sir.
So
Yeah,
if the light should go straight, that means the refractive index of the medium should be equal to the refractive index of the lens.
Yes, correct.
yeah.
That's the last part answer.
So
Yes,
can
sir.
you just tell me what will be 1 by R2 here in this
See,
question?
these questions you should not bother about the dimensions of the lens. It never change. If I put a convex lens from air to water, R1, R2 will not change.
Yes, sir.
So
So
what
not that. So no, I'm saying what will be 1 by R2 over here? No, not in the second part, I'm just saying. So will it be like 1 will be plus 1 by 20 and minus 1 by 20? Yes?
this is focal length given, no? How you can get R from that?
No, not 20, 40.
No,
R is equal to F, right?
that's only
See,
applicable to
That's only for
mirrors.
mirrors.
Only for mirrors.
This is lens.
oh, okay. I got confused.
Yeah, that time I told you even when you become expert at the end of the chapter, you use R equal to F for lenses also. Not
Yes.
use it.
So how do we find the radius of curvature then?
You don't want to
Anyone
find
knows?
the radius of curvature. I'll tell you. Can you wait just 1 minute? I'll just do a method. It's easy for you.
Yes.
One point, changing the lens from air to any medium will not change the dimensions of the lens. That's fine for you.
Yes, sir.
Yes, sir.
So we are not changing any physical structure for the lens. So if you tell me the formula, this is the formula. 1 by f equal to n2.
N2 by N1 minus 1
Yeah.
into 1 by R1 minus 1 by R2.
By R.
Oh, so have they given like another case like saying that like when then it's easy. Then we just need to divide and this both will get cut.
That's it. So when they say a lens has a focal length 20 centimeter, they will not tell you which medium. That is understood the lens is placed in air.
Yeah.
Every time when the medium is not specified, that means the lens is placed in air. Can you tell me out of N2 N1 which is the lens and the medium?
N2 is the medium, and N1 is air.
No, medium
Yeah,
means the
N2 is the
surrounding
lens.
medium. That's only air, no?
N2 is the lens. N2 is the
N2
lens
is
and
the
N1
lens.
is the medium.
Yeah.
So medium means surrounding medium, okay? Where the lens is placed.
Yes.
Okay, then I'll rearrange this as the first case we given n equal to 1.5, focal length equal to 20 centimeters. So the formula is 1 by f equal to, I'm changing n of the length by n of the medium. I changed n2 and n1. Okay, no confusion now. Then 1 by r1 minus 1 by r2. Now the first case, the lens is in air. Lens in air. So 1 by 20 equal to, what's the lens refractive index?
1.5.
1.5.
Medium.
1.
1. So 1.5 by 1 minus 1.
Minus 1. 0.5.
0.5 is 1 by 2, right?
Yeah.
Yeah. And I don't mind this part since it don't change. I just put it as k. This is k.
Okay.
Or x, whatever, because it's not affecting me anyway.
Yeah, it remains constant.
Yeah. So now you can get k, or like Darshan told, take two equations and divide. From this, k will come. You cut 2,
Yeah, 1 by 10 is equal to k.
k is equal to 1 by 10.
Yep.
Then go to the lens in medium. Lens in medium. So 1 by f, I don't know now. Okay.
Yes.
Equal to, what is the lens refractive index?
1.65 by 1.
Aditya, lens won't change. Lens is 1.5 before.
1.5. Okay. Yeah, correct.
1.5. By medium is changing. It was air before.
Yeah. So now 1.5 by 1.65.
Yeah, 1.65 minus 1. And k already you know what?
1 by 10.
1 by 10. You solve it, you'll get.
Yeah.
This
Okay.
will be 150 by 165.
Yes. So then 15 by 165.
Yeah. 1 by f will be.
Which is 1 by 11. So f will become 110.
Yeah, minus.
Yeah.
So I can tell you the possible mistakes because normally you don't take the first medium to be air. They will not tell you it's air.
Okay.
If they just say the focal length is 10 or 20 or 30 means it is in air. Otherwise, they should tell you in which medium. So that's the case one. Then
So
go to
if
case,
there's no medium, it's always air, right?
yeah,
That's vacuum.
yes, vacuum,
And
air.
that's the same as air, like the refractive.
Almost.
So,
If you get it now, I think this is not a hard question now actually. Two cases.
yes, sir.
Yeah.
It's easy only.
See,
So
I
then-
believe always when you try and you feel the difficulty, it's hard, you listen more to get the question answers. That's why the
Yes, sir.
questions are given in very well before you try, we discuss the mistakes. If we just post a question, discuss in the class, doesn't matter. Doesn't mean everyone will listen to that. But now you listen because you want to get the answers clear. That's
Yes,
the way
sir.
you get into your brain. Otherwise, it'll surpass here and there. Something you learn, something you don't learn.
Yes, sir.
And we are there to for you, like ask you any doubt to clear it. No issues in that.
Okay, sir.
Yeah.
So,
Yes, yes.
what is K here?
K, you know what is substituted as K?
Or that? Yeah, I understood. But then,
Yeah.
what is the value of K?
Okay, value of K is here, right? See.
So I can't
We
see.
found that.
See, if your video, that small thumbnail is just shifted somewhere else.
Oh yeah, yeah.
Or you can get it cut 20 and 2. It will come as what? 10, right?
1/10. Yeah.
Yeah, so K is equal to 1/10.
This is a very important question. So many years asked for the board. Okay.
Whoa.
Okay, sir.
See, once you're okay, tell me fine. Otherwise, ask me the doubt and we move from one to the next one. Like, we don't waste it.
So which question?
Now, this question is clear. Tell me yes or ask the doubts. Make it okay. Make a note of what you've done.
Sir,
Yeah.
so I have a doubt in the fifth worksheet, question 10.
So you should tell me the question. That's it.
Yes, sir, one second. The refracting angle of a glass prism is 60 degrees, and the refractive index of its material is 1.45.
Can I remove this clear off like
Yes.
others?
Yes, sir.
Okay.
Yes, sir.
Which question?
So I'll continue.
Yeah, 1 minute. Is it only TMS students in this or the others are there? DPS?
Sir, our own voice Sharjah.
Okay. I know Anirudh, right?
Yes, sir.
Okay. But are you getting these questions we're discussing?
Yes, sir. Just like I don't know what the question is. Like
Yeah.
I'm understanding the formula and concepts and all, but I just need the question. That's it.
All these questions are there in the book. That one.
Is it in the book?
Yeah.
Okay, sir. I'll check.
Or
I'll
I
search.
can, I think you are in Teams, right? It's uploaded in that? No.
No, sir. I don't think so. I couldn't find it.
Okay, it's fine. I'll send you that.
Which question?
No, next question. No, see, he is not in DMS, right? He don't know the question number you see.
No, I'm asking Kevin. He said.
Yeah, okay.
Worksheet 5, question 10. So I'll read the question.
Yeah.
The refracting angle of a glass prism is 60 degrees.
Okay, this is a
The
prism.
refractive index of it.
This angle is 60 degree, right?
Yes, sir.
Okay.
And the refractive index of its material is 1.45.
1.45.
Calculate the angle of incidence at the first phase that will just reflect internally the ray at the second phase.
Okay, fine. So this prism, first light ray falls somewhere here. We don't know how it's falling. So, but anyway, it's going from rarer to denser. So it bent
Towards normal.
towards normal. And they say on falling the second surface, what happened, Kevin? Just
that will
under.
so calculate the angle of incidence at the first phase. At the first phase, that will just reflect internally the ray at the second phase.
So just TIR means the light will go along the surface.
Yes, sir.
Yes, sir.
So you want to calculate this angle.
Yes, sir.
The refractive index is given as what?
1.45.
So where does the ray go? The out emerging ray?
The ray will go parallel to the surface.
Oh, okay.
Just TIR means it won't come back, it won't go to the next medium, it will go just parallel to the surface.
Okay.
Okay.
Yes, sir.
So this angle is R1, right?
So
Yes,
which
sir.
one? Yeah, that one.
What about the angle of emergence here on the second one?
90 degrees.
You were there or you just joined now?
Me?
Yeah.
No, sir, I was there.
Okay. This is 60. This angle is R1. If I draw normal here, this will be R2, and this angle is E, that is 90.
Yes, sir.
And you know the refractive index of this is 1.45. Apply Snell's law on the second phase, AC. What happens at AC, Snell's law?
So N2 by N1.
Yeah, N2, what is N2 and N1?
Sine. So N2
Sin
is
E
one.
by R2. Sin E.
So N2 is 1.45.
N2 is what?
No, sorry. N2 is
One.
N2 is 1.
The light is going from prism
Tensor.
to outside. Outside is 1.
Yes, sir. Yes, sir. So 1 by 1.45.
1 by 1.45 equal to
90
Sine
sine 90.
R2.
Sine E by sine R2.
Then you have to be careful. See, which is the
So
first
what did
medium? What's the
sine
angle of
R2 by
incidence?
sine sine R so R2.
Sin R2 by sin 90.
Yeah,
Sin R2 by 1.
sine 90. Yeah.
Is fine or confusing?
No, sir, I
No,
got
sir,
it.
it's fine.
So you have to be careful from where to where light travel. Okay.
Yes, sir.
Now from this you get R2, right?
Yes, sir.
So you remember, I don't know, when we learned this that A is equal to R1 plus R2. When you
Yeah, we
learn the
learned.
prism derivation, there
Yes,
was
sir.
result A is equal to R1 plus R2. Now you have R2, right?
Yes, sir.
Yes. Yes, sir.
So you know A also.
Yeah.
Yeah.
So you can find R1. Yes?
Yes, sir.
Yes, sir.
If you know R1, come back to AB. How Snell's law at AB?
So 1.45 by 1.
1.45 by 1
Yes, sir.
equal to?
Is equal to sine R1 by sine I.
Kevin, you are
Sin
confusing
I
still
by
me.
R1.
How you apply Snell's law? Tell me.
So sine of t.
See, don't worry. Tell me. I'll help you out how to find. Just tell me
You
what.
just tell the formula.
So
General
ratio.
formula.
So
I
ratio
don't
of
want any
sine.
wordings, mathematics. Just
So refractive index of two medium.
formula, N2,
Just the
N1.
formula.
Okay, so ratio of sine I to
There is
sine
no
R.
ratio. Sin I by, okay.
Sine I by sine R is equal to N2 by N1.
Yeah, that's it enough. Sin I by sin R equal to N2 by N1. Tell me what is N2 and N1 for you.
So for AB, right?
No, not this case. I left this case.
Okay.
I'm asking
So
in general.
So N2 is the refractive index of the second phase,
Second medium.
and N1 is the refractive index of the first medium.
And what
Sin
is
I is
I and R?
So I is the angle of incidence, the
Yeah.
angle the incident ray makes with the normal,
Yes.
and R is the angle refracted ray makes with the normal.
Okay. So tell me, come back to AB now. What is first medium for you?
First medium is n. First medium is n1. So
That is
refractive index
Now,
that
what
is
is the
what?
first medium?
air vacuum.
Air.
What is N2 for you?
N2 is the prism.
Yeah, that is.
1.45 refractive index.
And what is the angle of incidence here?
Angle of incidence is angle I. So
Yeah. What's the angle of refraction?
angle R1.
No.
Sine R1.
Yeah. Tell me then now the formula sine.
So sine R1.
Why
Sine
sine
I.
R1 you go?
Sorry,
Because
sine I.
yeah, sine of angle of incidence, no.
Yeah,
Fine.
sine I by sine R1
Yeah.
is equal to 1.45 by
1 point.
45 by 1.
It's fine.
Yes, I got it.
I didn't understand why you went for sine R1 in the beginning when you say.
So I equated N2 to sine R1. My
Okay,
bad.
maybe the other case you told me sine R2 by sine E, that's why you get sine R1 here also.
No, so I understood my mistake. I got it.
Fine. Now you got how to find what
Yes,
is
sir.
I didn't solve it. I just told you how to come back. Okay.
Yes, sir. Got it.
From this you get I because R1 you know 1.45 you know.
So I got IS 24.2.
Yeah, it's fine. I think that's the answer given also almost.
Yes, I got it.
Yeah.
Okay, I'll do that. Okay. So I have one more doubt.
Yes.
So in Prism, when we derived the formula, we got N2 by N1 is equal to sine A plus D by
A
sine
plus
A by 2, right?
sine A plus.
Sine A plus D, minimum deviation,
Yeah.
by sine A by 2.
No, sine A plus D by 2 by sine A by 2.
Yeah, sine A plus D by 2 by sine A by 2.
Okay.
So, but in the textbook it says for thin prisms you don't take sine, like sine theta is equal to theta.
Yeah, that we discussed now.
Yeah, so but one of the questions it asks us to calculate the minimum deviation. So which formula do we use?
See, thin prism means what you mean? Thin prism. Thin prism means the apex angle. This angle should be very small.
Yes, sir.
Like 2 degree, 3 degree, 5 degree, that range.
Yes, sir.
So only that case you can use the sign without sign.
Yes, sir.
The rest all cases you have to use a formula what you told me just now.
Okay, so if they give the so if they ask us to calculate angle of minimum deviation, we normally take the formula you're writing now, right?
Yeah. This is applicable to all the cases.
Yes.
Whether it is small angled or large angle, this is applicable to all the cases.
Yes, sir. Got it.
Small angle, you don't take the sign. That's it.
Yes, sir.
Yeah.
Sir, I have a doubt.
Yes.
So I don't remember which worksheet this was in, but I know that this question was like a previous board question. So it's the question's basically 3 immiscible liquids of densities D1 greater than D2 greater than D3 and refractive indices nu1 greater than nu2 greater than nu3 are put in a beaker.
Okay.
The height of each liquid is h by 3 and a dot is made at the bottom of the beaker. For near normal vision, find the apparent depth of the dot.
Okay.
So how do we approach this question?
Okay. If you do the apparent depth, you remember one formula we derived? Yes. You don't remember.
No, sir, I can't hear you.
Do you remember one apparent depth derivation we have done?
So is it nu1 by nu2 into?
That is actual depth by apparent depth.
Oh, okay. No, so then I'm not sure.
Okay. This derivation you remember?
Yes, sir.
Okay. So this case you have the result as down shift. The formula here shift.
Yes, sir.
So only thing is there are 3 media in that.
Yes, sir.
So find
It's given that
S1,
yeah, one is greater than yeah.
find S1, S2, S3 separately.
Yes, sir.
So you get the total shift.
Yes, sir.
And what they're asking,
So then they said for near normal vision, find the apparent depth of the dot.
okay. So how we find apparent depth normally? In this case, apparent depth. This is the left hand side is the actual depth, full length,
Yes, sir.
and the right top is
So
the apparent depth. How to
actual
get
depth minus shift.
yeah. So you can find the total shift using the formula, right?
Yes, sir. And then actual depth by nu one minus nu two. I mean nu one by nu two.
Yeah, I didn't say anything about that. I just told you find S1, S2, S3.
Yes, sir. Yeah.
That you'll find using the yellow colored formula, highlighted part.
Yes, sir.
After finding S1, S2, S3, to find the apparent depth is the actual depth minus the shift. What you got?
Yes, sir.
So if you want a workout solution, you send me that. I'll work out and send you back if you're not clear about this. What I
Yes,
told
sir.
you now, find shift 1, shift 2, shift 3. All the shift you get up add up to total shift.
So, but they've given the height of each liquid is h by 3. So, where do we use that in the?
Height.
Yes, sir.
What is the T in the formula?
Yes, sir. Yeah.
What is
That's
the
taken
T
as
in the
height, sir.
formula? What is T in the formula? T is the depth of the medium. That's each medium height.
Oh, okay.
When you find S1, T will be height of that medium.
Yes, sir.
So I didn't understand, sir. So what do you mean with T? Like, can you just go up and show me OB, sir? Okay, so OP is the actual depth. So
Yeah.
T is the actual depth.
Yes.
Okay.
So then we can take h by 3 as T, right?
See, there are 3 T's, right?
Yes, sir. Yeah.
Yeah.
There are 3
So
T's.
then you find S1, S2, S3.
Okay, sir.
Then add all the 3. You don't try to do
So I'm
now.
not clear of one thing. So if there are 3 T's, right, and they've given that the height of each liquid is h by 3, then I can apply h by 3 for each of the 3
Yeah.
shifts. Okay.
Yeah.
Yeah, then fine.
So either you do and send to me or send me the question so I can check. If you want a full answer, like if you're not clear about the steps how to do. Okay.
Yes, I'll try once and I'll send it to you, sir.
Yeah. Yes.
So, so in the fifth worksheet again, the fifth question, sir. An equilateral prism is made of glass of unknown refractive index. A parallel beam of light is incident on a face of the prism. The angle of minimum deviation is measured to be 40 degrees. What is the refractive index of the material of the prism? Then the
I
refractive.
want just once more you read the question. I'll just take down the details.
Okay, fine. an equilateral prism, so the apex angle is
Equilateral
60 degrees.
prism, angle of the prism is
60
60
degree.
degree. Yeah.
Yeah, is made of glass of unknown refractive index.
Refractive index we don't know.
Yeah. Then a parallel beam of light is incident on a face of the prism. The angle of minimum deviation is measured to be 40 degree.
Angle of minimum deviation is 40 degree.
Yeah. What is the refractive index of the material of the prism?
Direct question, right?
So?
Yeah,
Direct
it's pretty
question, right?
simple.
Formula is
Yeah,
around
direct question.
Formula is
So
given
then,
up.
so there's a second part also.
Yeah.
The refracting angle of the prism is 60 degree.
Yeah.
So prism is placed in water of refractive index 1.33.
Yes.
Predict the new angle of minimum deviation.
Okay. Same formula. You already got the refractive index of the prism, right?
Yeah.
So I'm changing the formula.
This time N1 will be water.
I'm changing the formula as n prism by n medium. Fine.
Yes.
So this is n prism you're finding here, first case.
Yes, sir.
So you get a value.
Yeah.
Now they're telling the prism is in another medium. So left hand side will become
different. It will become n prism by n water.
Maybe you get 1.53 for the prism here. Okay.
Yeah.
By water is given 1.33.
33. Yeah.
Equal to sine x by sine 30.
Yeah.
I've taken the whole term as x.
Okay, sir.
So you can get x from that, right?
Yes, sir.
After you get x, go back x equal to what?
A plus d by 2.
Yeah.
Okay, so done. That's all.
Yep.
Only thing calculation is there, 1.53 by 1.33 to calculate.
Yes, sir.
So we can take sine x as x, right?
Sine
X
No.
as x.
Why?
No,
no,
you can't.
do.
You can't do that.
It's not a thin prism because apex angle is 60 degrees.
So, and what should we find here? We should find angle of incidence, right?
No, they're asking the angle of
Deviation.
minimum deviation in the second case when you put in water.
Okay. Okay.
See, never try to use the formula for thin prism unless they say in the question it is what? Thin prism or the angle is
Prism, yeah.
close to 5 degree. Always use this formula only.
Okay, sir.
Once the doubts are over, you should tell me. I'll move to the next topic. That's it.
So it will be sine 50 here, right? As a numerator.
Sine
50.
First
Yeah.
question or second part?
Second part.
So second part.
Second part, how sine 50 comes? I don't know.
Like a plus d by 2.
Oh, that's the first part, no?
Oh yeah, that's what I meant.
60 plus 40 by 2, yeah, correct.
Yeah.
So I got the answer for that.
Yes.
I got the answer for that doubt I asked.
See, you follow the method what I say. If I start solving it will take time. That's otherwise no issues for me to sit and solve also.
No, sir, I understood.
Still
It's
not
fine.
okay, tell me back. Get me back sending this way or what's a mistake in that. I'll respond to you. Okay.
Okay, sir. Yeah.
Any more questions or I'll start with the topic?
So
Let's
you
start
can
with the
start
next
with the
topic.
topic.
So you can start the
Yeah.
topic.
So are we doing dispersion?
On dispersion we can discuss, no problem. I'll come to that now. Then we'll
So is it important or should we
it's
go
a small
to
one
instruments?
mark topic, not that great, but we should know that. That's it.
So we can move to optical instruments. It's fine because it's just facts, right? Dispersion part.
I'll just take 2 minutes, then we'll go because anyway you asked me, no? So, okay.
Okay.
I was finding an option how to go between. So I think I can manage now half on the paint and half in the other side because writing is hard in paint. Like, can you see the both windows?
No, so we can see only one.
Only one?
Yeah, so
Yeah.
I don't think we can see the paint. So.
Okay, then I have to
So
go
we
and
can't see
share the desktop again. Okay. I'm stopping the sharing. I'm going back to share screen. Share screen. Oh, I think it won't work together. Both will not work. Only thing, paint and word will work maybe. Okay. This you can see, right?
Yes, sir.
Yep.
Yes, sir.
Now you are able to see both.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now I just quickly do 2 minutes what dispersion normally happens. What is the thin prism formula you remember? Thin prism?
N2 by N1 is equal to A plus D by 2 by A by 2.
Thin prism, if you go, N2 by
N1
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 equal
is
to.
equal to A plus D.
2 by D.
So I can leave by 2, right? Sign will go for a thin prism.
Yeah. Yes.
Will come as
A plus D
Plus
by
D
A.
by
A plus
By-
D by A.
A.
Because 2 will get cancelled.
Yeah. So if you cross multiply that, I'm taking this as 1, okay?
Okay.
Here. And this is just what N. Easy, right?
Yes, sir.
Keeping the prism in A. Now, what will come if I take D from this?
AN minus
A.
A n minus A.
N minus A means A is common, right?
Yeah. A
Yes, sir.
into N minus 1.
N minus 1.
Okay, this can be even used for small d also because it won't be much different.
Yeah.
Yes,
For
sir.
a thin prism, it won't be that much different. So, if I have a formula like this, now what will decide the deviation?
So
So
the
N.
medium.
So A is
A is a
Constant.
constant for a prism.
Yeah.
So refractive index.
So N, right?
Yeah, N. So a prism have different colors falling on it when white light falls, right?
Yes, sir.
Yes, sir.
Different
White
wavelengths.
light have 7 colors.
Yeah.
Vibgyor.
Yeah, all the 7 colors have
Different wavelength.
different
Different
refractive
wavelengths.
indices.
Yeah.
Yes,
The
sir.
deviation will be
Different.
different for,
Different.
Different for different colors.
yeah.
Yes.
If this is a prism, when white light is falling on that, which one deviates more?
Violet.
Violet.
So violet deviates more, red deviates less because
Less.
the
Red has
refractive index of
Red has the greater refractive
most
index.
wavelength. Violet has the least wavelength.
yeah. So
Yeah.
violet and red. This is the reason for the dispersion. Okay.
Yeah.
Refractive index of different colors are
Different.
different. So deviation for each color will be different. Very specifically, violet have high refractive index, more deviation. That's why violet is coming towards the base, and red is coming little away from the base.
Yes, sir.
Okay.
So one doubt,
Yeah.
refractive index is related with wavelength with what equation?
You have a formula n equal to p by
Lambda not by lambda.
Yes, so okay, understood. And then V is equal to nu lambda.
yes, correct.
Yes, sir, understood.
So which formula could you repeat again, sir?
He's written it.
P equal to nu lambda in air by nu lambda in medium. So nu is same
Medium,
constant.
Yes, sir.
So n and the wavelength are inversely proportional.
Yes, sir.
There is another formula, but we don't want to go. That's Cauchy's formula. We don't have in the syllabus actually for refractive design. Yes. Done.
Yes, sir.
Yes, sir.
The next part is the optical instruments part. If you divide that into segments, there are 6 derivations in that basically. Something called symbol microscope, compound microscope, telescope. Each case there are two derivations. So first one, what's the idea of an optical instrument? What do you mean by an optical instrument?
So something that allows us to see an image clearer depending upon whether it's really far or depending upon the size of the image.
Okay, so you want to see objects more clarity, or you want to see the object large size? Yes.
Yes, sir.
Yes, sir.
Okay, so we should learn few points which help you understand the concepts as you proceed with the chapter. Number one, what is least distance of distinct vision? What do you mean by least distance of distinct vision?
So near point.
Yeah, that is the least distance and distance to the near point. Even
So
you know, just tell so that others can listen and we'll go. That's done, finished.
Okay, it's the least distance where an object can be placed in front of the human eye and where we can see it clearly.
Yeah, means if you start bringing an object from far away, the eye is able to focus the image on the retina till certain distance.
Yes, sir.
25
25 centimeters.
25, sir. 25 centimeters.
Yes, less than that, the eye
It's
is
not
not
a
able
clear
to
image
converge a clear image on the retina. It varies with defects of the eye, person to person, age, but average for a healthy human eye, the value of D is estimated as 25%. Means the visibility starts from 25 centimeter. The object is placed less than 25, it won't be clear to us. Yes?
Yep.
Yes, sir.
Now, what do you mean by far point?
So the furthest distance the eye can form a clear image.
Okay. Far point. For normal human eye, the far point is still what?
Infinity.
Only thing the image will be very, very minute.
Yes, sir.
Okay. So the range of visibility for a healthy eye is from
25 centimeters to infinity.
25 centimeter to infinity.
25 centimeter to infinity. Fine.
Yep.
The range. Now, you know what is short sight?
Yes, sir.
Yes, sir.
Yeah, just tell me what's short sight, just for understanding, not like what you can see, what you can't see. Like,
So you can see objects that are close to you clearly, but then you're not able to focus objects that are further away from you. And the condition
So
is
far
known
point is reduced.
okay. That means if you have human eye here, this is 25 centimeter point. Normal person should be able to see till last.
Infinity.
But a person with short sight only will be able to see till here, maybe 10 meters.
Yes.
Yeah.
Here, his vision is not able to help you find objects beyond 10. Right?
Yes, sir.
Okay, then how you correct this?
By using a concave lens.
So diverging lens.
Diverging lens. Why
Yeah.
diverging lens?
So that the rays can go farther.
Okay, now you can't see because they focus before the retina, right?
Yes, sir.
Yes, sir.
Okay. I'm approaching that in a different way. If I'm the person with this defect, my range of visibility only between
Yeah.
25 centimeter to
10 meter.
10 meter. Yes?
Yes,
Yeah.
sir.
Okay. Anything you bring in between this, my eye can detect as an image on the retina.
Yes,
Yeah.
sir.
Okay. Now I'm bringing a concave lens in front of my eye as a specs. Okay.
Yeah.
Now I'm keeping an object at infinity, far away, very far away. So this real object is only the object for the concave lens, right? You remember
Yes.
one lens, two lens, three lens, how it go? The first lens forms the image. That image light ray acts as the object light ray for
Object
the
light ray
second
for the
lens.
second. Yes, sir.
And
Yeah,
second
yeah.
lens forms the image that acts as the,
Object for the third.
yeah, that's what I asked. The first object, OB, is object not for your eye. This is object for the first lens, which is the first lens, the specs
Yeah.
lens. Yes,
Yes, sir.
Yes.
and that forms an image, right?
Yes.
Yeah.
That forms an image. That image will be the
Incident light ray for the eye.
yeah. That will act as the object for the actual human
Object.
eye.
Yeah.
Yes, sir.
Yes.
Yeah.
Yes, sir.
I'm not clear. Can you repeat? I want to know whether you're okay in the step, and we can go to the second step.
So basically, like OB is the object. Okay. So the image formed by the lens, the concave lens, will act as the object. The image formed by it will act as the object for the lens, for the eye lens.
Okay, eye, human eye.
Yeah.
Okay. So if this lens forms the image at 10 meter, right?
Yep.
Is it fine?
Yes, sir.
Yeah. Yes, sir.
Then I can see because it's within my range.
Yeah.
Yeah.
Yes, sir.
Okay, then if you bring the object closer and closer, automatically the image will come 10 meter less, 9 meter, like it will come within the 25 centimeter range. Fine.
Yes, sir.
Yes,
So
sir.
this is the role of an optical instrument actually.
So like the light ray from OB it will go to the concave lens and then it will diverge,
Yeah.
but then it will form a virtual image. Yeah.
Yes.
Am I?
Yes.
Okay. Yes, sir.
That
And then that will be
virtual
detected
light
by the eye.
rays, that virtual image light ray will be the actual object light rays for the human eye.
Eye. Yes, I understood.
And that will be that image formed by the objective will act as the object for the eye lens.
Yes, sir.
My question is where that image should be formed. It should be either between his far point or near point, right?
Yes,
Yeah.
sir.
Yes,
Then only
sir.
the eye
So
can
in his
detect
range of
the,
vision.
yeah. So what's the role of an optical instrument actually? Like a correcting lens.
So to converge or diverge the image according to the person's range of vision.
It should form an image within your normal vision.
Yes, sir.
Yes, sir.
So better at the extreme of that, so that the rest automatically follows, right?
Yes, sir.
If the object is here, you adjust the lens focal length in such a way it forms image at 10 meter, and you bring the object closer and closer, automatically the image will be in between this.
Yes, sir.
Okay.
Understood.
Yeah.
So
Yes,
this is even the role of normal all the optical instruments, not for correcting the eye. Okay. Here
Yes,
only
sir.
eye lens I use the concave lens for correcting the eye defect. So an optical instruments always form an image within your normal vision. Normal vision is from
25 to infinity.
25 to
25 to
infinity.
infinity. Okay.
Yes, sir.
Okay. Now, okay, leave it, come on the way. I think these points are clear. What's near point, far point.
Yes,
Yes,
sir.
sir.
Okay. Now I have to tell you one more point. What is called linear size and angular size? What do you mean by linear size and angular size? For an
So
object,
right now we discussed the concave lens. What about the
yeah.
convex lens?
Convex lens, okay, I'll go for that. I thought it's fine. But I didn't go for it.
Hypermetric.
So do we have that?
No,
Yeah.
I just discussed this for the concept of optical instruments, okay, not for
Okay, fine.
effects.
Okay, fine. Then next topic, sir.
Yeah. This is a real object. The length may be 10 centimeter.
Yeah.
This 10 centimeter length is known as linear size. Linear size basically means length.
Yeah.
To get an angular size of this, if you remember last year we have done the planet diameter, planet distance from the earth, like first chapter dimensions.
Yeah.
Get those two lines from top and bottom, where they meet,
It's a
that angle is
parallax.
called angular size. Yeah, parallax.
Yep.
Theta is called the angular size.
Okay, sir.
Now, the problem is linear size remains the same,
Yeah.
but angular size depends on where you take the angle.
Yes, sir.
So angular size can be very, very small for far away point, very large for close by point.
Yes, sir.
If you see a tall building from far away place,
It will be small, angular.
yeah, we feel it to be small, right?
Yes,
Yeah.
sir.
So our eye is normally feeling the angular size, not the linear size.
Yes, sir.
Okay.
Yes, sir.
So I have just found out, like it's not like here, it's kind of related. So, so how do we know what is angular magnification and what is linear magnification?
I didn't reach that level. Now we are coming to that only.
Yes,
All
because
these
that's
are,
confusing, sir.
sorry?
That's really confusing.
Yeah. Not confusing. We'll see that. I'm trying to make it clear. That's why I'm discussing these points as a background. The next point I'm coming to that only. Okay.
Okay.
This is clear. This linear size and angular size.
Yes, sir.
Now, what do you mean by linear magnification?
The height of object, the height of image by the height of
By
object.
height of object.
So this is actually linear size of the image and linear size of the object.
Yes, sir.
Means if you're seeing a object, the actual length of the object is height of the object. The height of the image formed by the instrument is height of the image. That ratio is called linear size of the image by linear size of the object, called magnification, or it's called linear magnification.
Yes, sir.
Yes, sir.
Okay, if this is
Yep.
2, what do you mean?
That means height of image is 2 times the height of the object.
Okay, means the actual length of the image formed is 2 times of the
Twice.
actual length of the object. Fine.
Yep.
Yes, sir.
But when I use eye for seeing faraway objects and optical instruments, actually we are not getting the real height of the object feeling. See, I'm sitting in my room and looking at a faraway building. I can see a mosque, tall, the top part of the mosque, but only thing I can feel to be like less than my half of the finger size.
Yes, sir. That happens.
So I don't have a
Yeah.
real feeling of actual height of the object, right?
Yeah.
Yes, sir.
Yeah.
So that is why we are leaving this term and going to a real feeling term called what?
Angular
Angular magnification.
Angular magnification. That is taken as what? Theta I
Theta.
by theta.
By theta O.
This is called angular magnification and even called magnifying power.
Okay.
If this is 2, what do you mean?
That means the angle that you make with
Formed
the
by the
image
image.
is twice of the angle made with the object.
Okay.
Right.
That means if we see with normal eye,
Yeah.
that angle is theta O.
So what?
You see an object with normal eye, no specs, no instruments, nothing.
Yeah.
Directly I'm viewing the tall building. What angle
Yes, sir.
I get from top and bottom to my eye is called theta O.
Yes, sir.
Now I'm bringing an optical instrument like telescope, because far away you can use only telescope, you can't use microscope.
Yes, sir.
Yes, sir.
The telescope form a magnified image. So that image top and bottom make an angle what theta I.
Yeah.
Okay.
That means the telescope will show you the image to be double the angle of the normal eye can see directly.
Yes, sir.
So we have a feeling the height of the image to be doubled, but actually the angular size only doubled.
Understood, sir.
The linear height is not doubled.
Yes, sir.
The linear height, still the telescope forming is smaller than the actual height of the building.
Yeah.
So like telescope and microscope, all the like they ask us to find a magnification, they always mean angular magnification.
Telescope and always angular magnification.
So because I got confused, so sometimes they just say magnification. So I think it's linear magnification. I get confused. So
Most
linear
of the
magnification
time,
always have a HO, and angular magnification depends on only on the angle theta I by theta.
and you can see some cases angular magnification will be same as linear magnification.
Yes.
You'll see on the way when it comes.
Yes.
So if this is a tall building,
So we take the. Okay. So can we take the theta as the arc length by radius,
yeah,
like we do sometimes?
yes.
Okay.
Actually, we do tan theta is theta approximately.
Yes, sir.
If this is a tall building, and this is my eye here, I'm getting the feeling of this to be very small, right? This much angle.
Yeah.
But if a telescope or something instrument forms the image of this here, is the size of the image greater than the size of the object?
No.
Yeah.
The angle
No.
is greater.
Angle is greater. No, what? Angle
Yeah,
always
Angle
remains.
is greater.
The angle is greater.
Angle formed by the image is greater.
So here linear magnification is less than 1.
Okay.
Linear magnification is less than 1.
Yeah, because image is
Angular
smaller than the object.
Yeah. This is a real size of the linear size of the object and image, okay? But you get a feeling you have a large angle or large image.
Yeah.
So now theta I is this full angle and theta is this angle.
So where's the telescope placed?
Telescope, you don't mind. I only want the image formed by the telescope. I don't mind where is the telescope.
Okay.
I'll
Yes,
come to
sir.
that. Don't worry. Derivations will come. This is a concept I'm trying to build. Okay.
Okay, sir.
So if this angle I'm getting is 3 degree and this angle I'm getting is 6 degree, I have a feeling of image double than the object.
Yes, sir.
I am having a feeling, but that's not true. The actual image formed is not double the length of the actual object. It is less. Yes?
Yeah.
Yes, sir.
So why we are dealing with magnifying power of an instrument, that gives us a feeling for the eye. What really your eye feel is in terms of the angle. That's why even a moon, very large number of kilometers in diameter, you can simply cover with half of the thumb or nail of the thumb, like, so it
Yes,
only
sir.
give you feeling of that much size when you look directly.
Yes, sir.
But if I use a telescope to form a very small image of the moon compared to the actual size of the moon, still I feel that to be large. No.
Yes, sir.
Even a telescope is forming a small size, small linear size of the moon with respect to the actual size of the moon. Since it is formed close to my eye, it's up at a large angle.
Yes,
Yeah.
sir.
The same direction is going another way. This is a moon. My eye is getting only a small feeling. I can't draw more than this much image.
Yes, sir.
But if the telescope here forms a small image of the moon, which is smaller than this, it will give you a large feeling of it. Yes.
Yes, sir.
Yes, sir.
So this is the meaning of angular magnification. And telescope cases, only angular magnification is greater than 1. Always a linear magnification will be less than 1 for telescope. Because telescope never form an image really larger than the actual linear size of the object. It's not possible.
Yes, sir.
So I think you got some idea of what is, I basically discussed what is least distance, far point. And I told you one concept, when a lens is used in front of the eye, what really happens is the actual object is the object for the optical instrument. The image formed by the optical instrument is the object for the eye.
Okay.
Yes, sir.
And that instrument should form the image within my normal vision if I want to see. No?
Yes, sir. Yes, sir.
My normal vision means 25 centimeter to infinity.
Yes,
I'm
sir.
waiting for the clarification. Even I don't know this is okay or not, but this will help you to understand what we are doing why in the next part.
Yes, that's fine.
And we are approaching what we see really with the eye, how you feel when you use an optical instrument. We are not dealing with their real size. Real size is only dealt in what? The linear magnification.
Yes, sir.
In angular magnification or magnifying power, we are checking the angle formed by the image with respect to the object so that you feel that much enlargement for the image with respect to the object. That's a feeling for that.
So we're saying that basically the telescope just provides a feeling that it's actually magnified because of the angular magnification. That's what we
Yes.
feel.
Yes.
Whereas the linear magnification is actually much like significantly smaller than what we're feeling.
Yeah.
Yes, sir.
If one more point I tell you, I don't know, I'm just restricting because I don't want to confuse. I'm trying to tell what all you are getting clear. Like, if I have an object here, like a moon, right?
Yes, sir.
It's an angle formed by the moon. I can feel this moon as this much size if it is kept here. This much size is here. Like, actually, it's what very, very smaller size, but the angles will remain the same.
Yeah.
It's the feeling what we're getting.
Yes, sir.
Now, when you discuss theta I and theta O, the problem with theta will not be constant for every point, right?
No,
I have
sir.
an object here. Object. No problem, the linear size remains the same.
Yeah.
But angular size depends upon where
The
you take the
distance.
angle, right?
Yeah.
Yes,
Even
sir.
depends upon where you keep the object also.
Yeah.
So all theta cases, I should tell you very clearly where you find the angle with the object at what point.
Okay.
Whether you use the optical instrument, telescope, microscope, or you don't use the optical instrument, that should be specified. See, all magnifying power derivations or the calculations are done in such a way. You are comparing the maximum capacity of the eye, maximum capacity of the eye with the instrument. Means, what should be theta O?
Infinity?
Infinity, I feel angle to be very small, right?
Oh, that is linear, right? Wait.
Yeah.
Okay. Theta O.
See, when I get maximum size for the image,
When image is at
When
25.
it's close, yeah,
Right.
25, close to the eye.
right?
Yes, sir.
Yeah.
Between F and O.
Yeah.
Which F and O?
F and O, yeah.
Here there's no lens,
Okay, yeah.
only eye, human eye.
Okay, sir. Yeah, yeah.
I'm bringing a pen from far away, close to my eye.
Tuition.
Yeah, I will feel the pen to be largest size when it is at,
Distinguishing.
yeah. If I bring lesser than that, it's feeling to be large, it won't be clear. No use.
Yes, sir. Unfocused.
Yeah. So for a microscope, always theta O should be measured with object at the
25 centimeters.
near point, 25 centimeters. Why? Because
So only then we obtain a clear image.
not only clear image,
Most
I can have clear
magnified.
image before 20, after 25 centimeters also.
The image is most magnified at 25.
That's a maximum capacity of the eye. And we're checking that capacity as how much times an instrument can provide, how much times an instrument can provide, how much times of this capacity.
Yes, sir.
Yes, sir.
So, but how can theta be 25? Like, theta is an angle and 25 is like centimeter.
I didn't say angle is 25. I told you the object
At
should be at 25 centimeters when you measure that.
Okay, okay, sir.
Because see, that's a position, how much you can try bringing the object closer with clarity.
Okay, sir.
So we are trying to compare what with what. We are trying
The
to
image with the
compare the
object.
capacity of the instrument with maximum capacity of the eye.
Okay.
Not minimum maximum capacity of the eye. We take only maximum capacity of the eye and whatever capacity of the instrument.
Okay, sir.
For example, I'm keeping this object at 25 centimeters. This is my eye. If I'm keeping an object at here, this point, I'm getting an angle of 5 degrees. Okay.
Yeah.
Yes, sir.
So now I can bring an instrument here, lens, whatever. Yes.
Okay. Yeah.
Now I can bring this object further close. Why?
So because there's a lens as well as the eye. So it will converge the image and then it will be seen in the retina.
This is what I told you. When I bring an object here, if the lens is not there, can I see clearly?
No, sir.
No, you can't.
No. But when the lens is there, this object is not the real object for my eye.
Yes, sir.
This
It's
is the
the
object
virtual
for the
lens.
lens only.
Yes,
Yeah.
sir. The
I
Yes,
don't
sir.
bother about the object. I bother about only where the lens is forming the image.
Yes, sir.
And you know, when you draw the diagram with this object, the lens forms the image behind the object, right?
Yeah.
Yes, sir.
You don't understand. I'm keeping the actual object close to the eye
Yeah.
Yeah.
with the help of a lens. And I'm
Yeah.
being very specific, telling you I can't see that object clearly if the lens is removed.
Yeah.
But I keep the lens in between. I'm very clear to keep the object closer, less than 25, because I'm sure it is not a direct object for my eye.
yes, sir.
The lens
Yeah.
will form an image.
Yes, sir.
I
Yeah,
only
sir.
bother about where is the image formed by the lens.
Yes, sir.
The lens
So, like,
have to form the image either at 25 or anything beyond 25. Then my eye is able to see that.
Okay, sir.
I don't
so,
know
sir,
if
like basically for our eyes, the minimum distance is 25 centimeter. But if we put a lens, the lens will be the object for us. So it doesn't matter where the actual object is. If we keep it less than 25,
doesn't
like
matter.
yes, sir. Like,
But
but it should be like behind the lens.
yeah,
Like,
what matters for you where that lens is going to form the image, which act as the object for the eye.
yes,
Okay,
sir.
sir.
That should be either at minimum
25.
25 or beyond 25. I don't mind.
Yes, sir.
Yes, sir.
Only for this point, I introduced the short-sightedness in between.
Yes, sir.
See,
Understood.
I'm trying different way. I am doing 2 classes, then I'm doing class outside. I'm getting the feedback. Which point you're not getting? I'm trying to, but they change my approach to you. Okay,
Yes,
that
sir.
we're getting a different
Yes, sir.
treatment now. I'm thinking like how to improve the concept what you're getting. I don't know still. It may be little complicated for you, but this is another way. Try it like how to get the concept.
Yes, sir. We understood.
So with the help
No,
of
sir,
a
yes, sir. We understood this. We understood.
Yeah, with the
And
help of a lens, I'm able to bring an object even lesser than 25 centimeters.
Yes, sir.
But that doesn't affect me because I'm not seeing the direct object. I'm only seeing the image formed by the lens,
Lens.
which act as object for my eye.
Yes, sir.
The only condition is the lens and the object should be placed in such a way this image formed by the lens supposed to be minimum 25 centimeters away from the eye or more than that.
Or beyond it. Yep.
Yes. I think if understood, that's the best understanding of the concept.
Yes, sir. So that I understood. But then, sir, in that part you said maximum capacity. So why is it maximum there? How is it maximum capacity?
Okay,
That's
maximum
maximum capacity of the eye, not like with the lens.
Okay.
Even
Bro,
with the
they're
lens, I can
saying
tell you now. See, I
they're
told
saying
you-
maximum. Okay, sir, you can.
I told you what is theta O.
Yeah.
Theta O comes without the help of any instrument, no instrument.
Yes, sir.
So how much you can see maximum for a pen? What angle?
25.
No,
At,
no.
like
Yeah,
when
when
it's
it is
25
kept at 25 centimeter, right?
Yeah.
When the pen is placed at 25 centimeter, it will be the maximum angle for you.
Yeah, right. Maximum angle will come. Yeah, yeah.
That's the maximum capacity of the eye. I cannot see anything more than that angle.
Yes, sir. Correct. Understood. Yeah, that I understood.
Okay.
Yes, sir.
Now, see the
Yeah.
same pen I'm bringing close to the eye. See, this was the pen here before.
Yeah. Yes,
Now
sir.
I'm bringing it close. I can get a more angle, right? See,
Yeah.
that
But
will be the
that
same
would
as
be
image
clear.
formed here, right?
Yes, sir.
So these lenses are trying to increase the theta for me,
Okay, sir. Understood. Yeah.
but that theta is because of the instrument. So we'll call it as theta I.
Okay. Yeah. Yes, sir.
So now this theta I feel much greater than that of the theta O.
Yes, sir. Angular magnification.
Yeah. And very important, this distance between the lens and the object should be adjusted in such a way the image formed by the lens
Yeah. Should
should
be
not be less than
at
25.
Yeah. Yeah. So it should be
It can
at
be
or beyond.
25, 30, 40 till what infinity, no issues.
Yes, sir.
So where the instrument can give you the maximum power then? When the instrument, now the eye is over. Which case the instrument, the lens, will give you the maximum power? Okay, tell me
The
when you keep
closest,
the
also closest to the lens.
Yeah, closest to the
Yes, sir.
lens.
When it's close to the lens,
yeah,
then theta
that
will be
means
maximum.
you should find the object distance for the image distance to be 25, right?
Yes, sir.
You should find the u value of the lens with the object, where the v value is what, 25.
Yeah.
That's a near
Yes, sir.
point. That's called near point adjustment for an optical instrument.
Yes, sir.
The object is kept in such a way the image is formed at what, near point of the eye.
Yes, sir.
Okay, sir.
Okay, then
So I wasn't clear about one point.
yes.
So so you mentioned that so that when the image is formed closer, then it can be even 20, 30, or 40 behind. I didn't get that point, sir.
The human eye can see from where onwards?
25 to infinity.
Yeah, so 25, then 30, 40, 50, all you can see, right?
Yes, sir. Yeah.
Yeah, that's what it is.
Okay.
So the lens must form the image at a point either 25 or
Closer.
after 25, not closer.
Okay, sir.
Oh yeah, sir. Yeah. So
Till
that
where
was
you
the
can
one form in
go.
the range.
Yeah, till where you can go, till infinity you can go.
Yes, sir.
In that, I'm asking which image formation the instrument will give you the maximum theta I.
So
I
theta
have an
I
image
will.
formed here. This is a theta I, right? Image is
Yeah.
formed here. This is theta I. Image is formed. This is theta I. Like which case I get maximum theta I?
So the
When it is at 25.
closest
Yeah, when
at
it's
25.
closest.
The image formed by the convex lens is at 25, right?
Yes,
Yeah.
sir.
Okay. When I get the minimum,
So
When
when
it's
it's
at
at
infinity.
Like at infinity.
Infinity.
infinity. So I'm comparing the minimum and maximum capacity of the instrument with the maximum capacity of the eye.
Yes, sir.
Yes.
For
okay.
example, I told you directly 5. Okay.
Yes, sir.
The instrument will give you maybe 25 directly at, I mean, not 25, 35. When you keep a 25 centimeters image formed by the lens. Okay.
Yes,
Yes,
sir.
sir.
So you get 7 times angle than the direct eye, right? 35
Yes, sir.
by 5.
Yes, sir. Yes, sir.
If it's formed very, very far away, maybe I'm getting a 10-degree angle.
Yeah.
So I get what, 2 times angle magnified.
Yeah.
Yes, sir.
Maybe less. I'm not telling always magnified. Okay.
So, sir, at infinity, can we say the theta is approximately equal to 0 or somewhere like that at infinity?
We don't take 0. It's infinity does not mean infinity. Very, very far away, comfortable. That only it means. Okay. Infinity, you can't see a particular size, very small size.
Yes, sir.
It's the only thing without much strain for the eye, far away. That only it means.
Yes, sir.
Yes, sir.
Infinity is a concept. You can never reach infinity. Okay.
Yes, sir.
Yes, sir. Yeah.
When you do theta I by theta O, we will do 2 cases. Theta I with the image formed at near point and theta I with the image at far. But theta O we don't think. That's always at
25.
Because I don't want to test my eye's minimum and maximum capacity. What I want to test is how much maximum I can now without an instrument. How much more the instrument can give me, more or less, like with respect
Okay,
to
sir.
So that's the reason if you go for a discussion, we always take theta O as what? Object at 25 centimeter or near point with no instrument.
Okay, sir.
So how we define theta O? It is the angle made by the object at the eye when there is no optical instrument placed at what? 25 centimeters.
Yes, sir.
Yes,
So
sir.
keep the object at 25 centimeter. If it's not 25, bring the object to the 25 centimeter at least. Draw top and bottom. Get the angle at the eye. This angle is called what? Theta O.
Yes, sir.
Yes, sir.
Then what is theta I? If you want maximum magnifying power, keep the instrument in such a way the object is brought closer.
Yes.
And you adjust the
Make it-
distance in such a way this object, the image is formed at what again? 25.
Okay.
So that theta I. So when you say theta I, what all should specify? The angle is subtended at I
Yes.
by the top and bottom of the
Bottom
image.
of the image.
Where is the image formed? There are two options for
At,
you.
at 25 or beyond.
If not beyond, we only take the extreme cases.
Okay.
At 25 or infinity.
Yeah, near point or far point.
Fine.
So I'm just confirming one last. What is theta O? How do you find theta O? Can you tell me?
Theta O is the angle made by the object by the eye when there is no optical instrument.
I think one point you missed still.
Dude, you sound like Terminator. Something's wrong with your audio.
Check your Wi-Fi.
Kevin?
Sir, can you hear me?
Yeah,
Some
but like,
vibrations along with your sound.
So, okay, I'll leave and join. So,
I don't want a formal definition. You can tell me point wise
Fine.
1, 2, 3, 4. Yes.
hello.
so,
Yeah.
so can I leave and join? It's not clear.
Yeah, fast. Can someone else try while he join?
No, sir, I'll try.
Okay, fine.
Okay, that's
Yeah, it's okay.
no, sir, it's okay. Okay then. So when object is placed at near point, and two arms subtended from the top and bottom of the object meeting at one point, that is the eye, it will form an angle without the need of a lens, and that angle is theta O.
It's fine. Right. We understood.
Yeah.
Now, what is theta I?
So I should answer or someone else?
I'm okay with both. Anyone else can try.
Okay.
Darshan, one call is waiting for you. Like I already asked.
So I didn't get you.
Can you tell what is theta I?
What?
Theta I.
So I couldn't hear you. Can you tell again, sir?
Theta I.
Yeah, theta is the angle from the image. Like the it's apparent angle, sir.
So you should tell me where you measure the angle with the image where. That's what I want.
Oh yeah, to find angular magnification, theta by theta O. It's like apparent angle, angle.
Bro, where is it measured? Like
Which point you find the
Like
angle?
you draw the two arms and stuff. Like
Where's the angle formed?
Yeah.
That's what he was asking.
Oh, so like, what do you mean? Okay, it's like formed. It's formed like in terms of an eye, right?
Yes,
It's
it is
formed
formed
at the eye.
It's formed at an eye.
Between joining what? Joining which all points?
It's joining the bottommost part of the object and the topmost part of the object.
Image, right?
Yeah. Of the image. Sorry.
Yeah.
Sorry. Yeah.
When means where the image being formed.
So image being formed. So it's formed between the area of distinction at the near point. Like depends. So for least strain, it will be formed at distinction at F.
Yeah. Otherwise.
Otherwise, it will be formed at the near point between the distinction between 25 centimeters and 0 centimeters from the eye.
I'm not clear.
So like for when there's strain, like no strain, it will be formed at the focus. When there is strain, it will be formed like at the near point of the eye. Like it will be formed within 25 centimeters.
So can you see then within 25? You know, we can't see anything within 25.
So that's called strained vision also.
No, strain vision only 25. Even below 25, you can't see if when you strain the eye.
Yes, sir.
Hard to see.
So
Maximum.
so is it infinity?
Yeah.
Okay.
So I want someone else to tell once more because it came with bits and pieces, right? Kevin joined back.
Yes, sir.
Yeah, theta I first.
Theta I is the angle subtended at the eye by image at infinity or near point.
Okay. Angle subtended at the eye by the image.
Yeah.
When it is formed?
At infinity or near point, 25
Yes.
centimeters.
Okay. That will be asked in the question. Okay.
Yes, sir.
Okay. Now we are coming to the derivation of each case. Like what is say, there are microscope two type. One is called simple microscope. One is called compound microscope.
Compound microscope.
Yeah. Do you want me to show the diagram by stepwise, or I can just show the diagram what's already there?
So just show the diagram, so it's fine.
Is it fine?
So can you show the derivation of the diagram?
Derivation is fine. I'm asking, do you want me to show the stepwise formation of the diagram?
Yes,
Or
sir.
you can tell me yes. I don't
Yeah.
want.
Yes, sir.
Yeah. It's not stopping you from asking. I'm just
Okay, sir.
asking only it's clear or no. That's what I mean.
So
So I'm
stepwise
doing.
formation.
Sorry.
Stepwise formation, sir.
Yeah. I'm starting with simple microscope. Simple microscope. With I can have two options. The image can be
Near point or
near point or far point. Now I'm doing for near point. Near point means
At 25.
25 centimeters. The image. So this is a convex lens, single convex lens. This is the principal axis. Should be bisecting the lens.
Yes, sir.
When you mark F on both sides. Okay, this point is C, center of the lens. I'm marking just F, not F1 and F2. Both are equally away from the center, okay? And where you should keep the object for in near point image formation.
So between F and the optical center.
Okay. the object is placed between the F and the optic center. Don't keep close to F, because if object is at F, where is image formed?
At infinity.
At infinity.
So it's hard to get within the paper, okay?
Yeah.
So keep midway between the object and the focus and the center. Rule number 1.
Parallel to the principal focus.
So it goes to the focus. Yeah.
Second one passes through optic center.
So then you have to extend the rays backward.
Yeah.
So that they meet.
With dotted lines and arrows.
It'll be virtual image.
Yes. So you need to draw the image, otherwise you won't get it clear for the exams before if you don't try. I will draw the image here.
So doesn't it use 2 convex lens?
This is simple
That's for
microscope.
compound.
Simple microscope.
Simple, yeah.
Simple, only one lens.
Okay.
And this is the image. Now, as the question says, the image is formed at
Yeah, point.
near point. So the image point I'm taking as from here to here, CI.
D.
D.
That's D equal to D. But minus, because
Yeah.
Yeah.
Sign
it's
convention.
light ray.
That's right.
Point.
Now this is the arrow mark for the light ray. So compulsory. Otherwise, as per
Shani
the
sir,
book.
it's fine. Like it's understood.
Yeah, it's
We'll
fine.
do it in exams.
Yeah, that's what I'm asking.
Yeah.
So the arrow
So
mark
you
is
don't need to
compulsory. If you
remember.
don't have an arrow mark, you lose half mark minimum. Okay. Now find theta I and theta O.
So you're breaking your voice.
Maybe the connection sometimes not stable. That's a problem.
So it's breaking.
The internet connection maybe sometimes become unstable.
Yeah.
Amir, is that you?
C2O is you,
Who's
right?
making the sound?
No.
Okay.
Yes.
C2 was you.
Yeah, object distance is C2 only, right?
Yeah.
Yeah.
Yes, sir.
Now tell me what is theta O?
So angle BCO.
Angle BCO.
Yeah.
Okay. Can you tell me theta O when you measure what all precautions you should take?
So
We should
see that both the arms from the top and bottom of the object must be in the
Yeah.
axis.
Then so I'm just verifying what
so we
you
also have to
right or
make
wrong.
sure
You don't
that
stop. You don't want to stop speaking to me. I'm just verifying what you're taken is correct or not.
So angle should be formed at the eye.
Yeah, I am taking a C. Okay, because all
Yes.
microscope we normally keep the eye close to the lens. You can see all the
Yeah.
videographers keep the eye close to the lens.
So also because we took CI as D.
Yeah. Then see, I just told you. You told me some points, Aditya. You only told. Just check all the points
Yeah.
are satisfied.
Okay, so the arms are meeting at C and
Yes,
we are
correct.
taking C as the eye.
Okay.
There is no lens in between that. So
Okay,
it should be
fine.
fine.
That's only the condition you told me.
Oh, BO should be at near point. So we should take BO to I.
So the object, the first thing is, the first priority is the object has to be at the near point. Is at the near point?
No.
No, sir.
No, sir.
No, sir.
So we should take it to I.
Yeah, there are two options for you. Either draw a temporary image at the near point or get the angle. Or second option, I'm drawing another diagram here down. Exactly from C, this point is C, this point is I, and I'm transferring the object, this object to that point. I can draw the same here, okay?
Yeah.
Yes, sir.
And this angle is called what?
Theta O.
Theta.
Theta O.
Theta O.
If I mark the letters, this is C. This point is B, exactly B. This point
So
is
it's the actual
O.
height, right?
I.
Yeah, this actual height. Actual object is transferred to the near point.
Okay, fine.
Okay.
Okay, sir.
So you can draw it in the same figure itself, right?
Yeah, you can draw in the same figure. You can draw outside the figure also.
This is to avoid confusion. That's
Yeah.
all.
Don't see
Sir,
so many things.
So
Well,
it's
we can
fine if we
compare.
take the same letters, right?
Yeah, same letters. So see, easy to understand. Let's see.
Okay.
The only thing is O is transferred to this point.
Yes, sir, got it.
So should we mention?
Yeah,
Like,
you
should
can
we write a
see.
statement?
Yeah, yes.
Okay.
Then this angle will be
Theta O.
Theta O.
Theta O.
theta. Which theta?
Theta O.
Theta O.
Then how to find tan? How to find theta I?
So we have to join
So MCI.
Yeah, top and bottom of the image to the eye.
to the eye.
So this angle will be theta I.
Yes.
Yes, sir.
Yes.
Yeah.
Okay.
Yes, sir.
Even you don't have the image, you can find theta I. See, this triangle is enough.
Yeah.
Theta I with this triangle you can do, even with the full triangle you can do. Full.
So, but full triangle is better, right? Because IC is equal to OC.
Then that distance get cancelled, right?
Yeah, that's why.
No, I want V by U that way.
Oh, okay.
So I want the height to be cancelled, not the length.
Okay. So then
I
you can take.
Yeah. I don't know you listen to this point. This point is important for the next case where I told you the image is not compulsory for theta I. The light ray from the image is enough. With the object, you can find theta I.
Okay, sir.
So if it's fine, you're going for the derivation, magnifying power equal to theta I divided by theta O. Yes?
Yeah.
Yes, sir.
So how to find theta I and theta O? I mean, how to find, I'm changing this as theta I as tan theta for small
And
aperture.
theta.
Yes, sir.
Yeah.
So M equal to tan
Theta I.
theta divided by tan theta O. Then you go to the triangle and find out what is tan theta and tan theta. Equal to tan theta is better to find from the small triangle.
So BO by OC.
Yes. Tell me now tan theta.
So BO by OC.
Yeah.
Yeah.
OB by
OC.
OC.
yeah CO. Fine. Then divided by
So can you scroll down for the diagram?
yeah.
OB, no, CO by OB into CO by OB.
Divided by OB by
by
CO, right?
Yes, sir.
Yeah, divided by OB by OC. Hello?
Okay. There's a problem if you mark OB like that. I'm changing this B as B dash, okay?
Yes, sir.
Because this OC and this OC are different, see?
Yeah.
I'm marking this as B dash. And this point is O dash.
Okay.
You understood why?
Yes, sir.
Yes, sir.
Otherwise, I'll get the same distance get cancelled.
Yeah.
This point is O dash. So it will come as
BO dash by CO dash.
okay. When you take the reciprocal,
Oh, yes, sir. CO dash by BO dash.
CO dash by
BO dash.
CO dash by O dash B dash, right?
Yep. O dash B dash. Substitute values.
Substitute the values.
HO. So do we take OB as HO?
No, OB and O dash B dash get cancelled, right?
Yeah, cancelled. Yeah.
And what is left?
CO dash by CO.
CO dash
Which is
by
V by U.
divided by CO.
CO.
That will be equal to V by U.
Yes.
So where is Darshan? Darshan is there.
No, sir. He went somewhere.
Okay. So if you see him tell, you can see the magnifying power here. What you see same as the normal magnification.
Yes, sir.
So in this case, the magnifying power is same as the linear magnification.
I don't know.
This is completely went.
What just happened?
Yeah, it went to the home screen, like, and then it pulled me back.
That thing, yeah.
Shani sir?
Yeah.
Oh, okay.
Fine.
Yeah.
Yes, sir.
Yes, sir.
Okay. In this particular case, you can see the magnifying power you got is same as the linear magnification.
Yes, sir.
As I told you, some case it's same, not every case. Okay. Now,
So now we have to substitute.
yeah,
V
the
with
problem is the right hand side values all are not constants. V, you know,
Yeah.
right? But
Minus D.
U, we don't know. So
we
U
are
can be
leaving it here,
converted.
going to length formula and changing that. 1 by V
Minus 1 by U.
1 by U equal to 1 by F.
1 by F.
From that, multiply throughout by V.
So
Yeah.
So V is constant, right?
Yeah, V is constant. The same I want V on the right hand side. See?
So we can take 1 by U to the right hand side and take 1 by F to the left hand side. We'll get
Yeah,
1 by U, right?
fine, correct. I'm doing that only.
Oh, okay.
I multiplied with V. So you can see what has come now.
1 minus V by U.
V by U is equal
Now,
to
now
V
do
by
what
F.
you see. It will come as 1.
V by F plus V by U is equal to 1.
And this is M, right? V by U is M, right?
Yes,
Yeah.
sir.
So you can combine, you get a formula as M equal to
1
V by
minus
F
F.
minus 1.
Plus 1.
Yeah.
That will be equal to 1 plus D by F. Why? Because the value of V is equal to minus 2.
Minus D, yes, sir. Yes, sir.
Yeah,
Fine.
that's fine.
So now all the factors are constant on the right hand side.
Yeah.
Just by knowing the focal length, you can find the maximum magnifying power.
Yes, sir.
If focal length is 10 centimeters,
1.25. No, 3.5.
F equal to 10 centimeters, M is equal to 2.5 plus 1, 3.5.
Yeah.
F is 5 centimeters,
6.
6, yeah.
Yes, sir.
so M is equal to 5 plus 1, 6.
6.
In short,
Yes, sir.
focal length lens help to increase the magnifying power. Shorter the focal length, higher the magnifying power.
So I have to leave, sir.
Yeah.
Thank.
So next day we can start by 9 o'clock then.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
We don't want to waste time, like, okay. So tomorrow is fine, 9 o'clock then.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. So if you go through this clearly, the next day it will move fast. Okay.
Yes, sir.
Okay, sir. Okay.
Tomorrow I'm
Thank you,
keeping
sir.
a 9 to 11:30.
Okay, sir. Fine.
Yes, sir. Thank you, sir.
Okay.
Thank you, sir.
Yes.
Thank you, sir.
Thank you, sir.
Amir?
sir.
Yeah.
You'll send the meeting ID, right?
Yeah. I'll send you today.
So you can save the recording.
Yeah, I'll just share.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
Shani, sir.
Yes.
So